So today we're going to talk through some questions, some in-class question example questions for conductors. And this is our last week of content, so we've almost made it to the end. I hope everyone is staying sane. I hope everyone is getting the answers to the questions that they have. If you have questions for this course, please reach out to me either by email or through our anonymous question link from the homepage of our Canvas course. But looking at week 14, conductors, we're going to heavily use the NEC 310 conductors tables PDF. So this is a PDF file that be helpful to have downloaded, helpful to review. We're going to talk through some of these tables as we work through some of the questions today. So turning to our questions, we'll start with question 1. So we have an overarching application scenario where we have a 120 volt single phase 2.5 kilowatt rated load with a power factor of 1. So we know this is a purely resistive, or at least there's an equal amount of inductance as capacitance. It's located, so the load is located 525 feet away from the power distribution panel. Both the load and the power distribution panel are located within a food processing building. So that's a hint at the environment it's in. Food processing a lot of times are wet environments. They're clean. They're sprayed down routinely. There also can be, during the processing, can be liquids in the facility, right, in the environment, but definitely every so often they're sprayed down. All conductors are installed in metal conduit. So those are some hints on the environment, the setup of the system, and the distances, right? But we're going to follow then down through looking at that example application, and we'll work through a bunch of questions that relate to this setting. And so looking here, I'm going to add this away so I can get at that. So we want to draw the electrical diagram depicting the branch circuit. So the circuit that is powering this single phase 2.5 kilowatt load. So I want to draw this branch circuit that's powering that. Clearly label all the components, including dimensions. And so we had a dimension of 500 feet and 25 feet. And so if I were to draw kind of a one line or a simple line drawing of this, I'm only going to draw one line. I'm not going to draw the neutral and the hot, just a single one line, and we'll put some notes on how many conductors that is. I would have my panel here. It is 120 volts. It is a single phase, right? And I have my load. Of course, I have loads outputs as circles, and this is my 2.5 kilowatt load, and it is a power factor of 1. So I have my power factor of 1.00, and I have my distance from my panel to my load at 525 feet. So some rough dimensions of, right, the estimated distance and the details on the load. 2.5 kilowatt, power factor is 1. It's a single phase 120. So that is my kind of overarching circuit. Of course, I've only drawn a single line. We can envision this as 2 conductors off of that panel, a neutral and a hot. Of course, there's a ground, which we usually don't count, or it's assumed rather. Every cable has a ground, right? So if I say 2 conductor, we assume it has a ground. The other way I could draw this, maybe a little more in line with what we've drawn at the beginning of the semester, is this. And of course, this would go to my black, white, right? But I'm going to actually have us start drawing a simplified version with detailed callouts on how many conductors we want for in that line. So that line is actually a 2-conductor cable. So that's the answer to our first problem. A panel, 120 volt panel, single phase, powering a 2.5 kilowatt load, 525 feet away. The power factor of that load is 1. We've identified the locations and the distance and 2-conductor.